Hello, everyone. I would like to start with 3 questions for you. So, first one, how many of you are running your applications on Kubernetes? You can raise your hands. Okay, that's expected. How many of you rely on multi-zone high availability for your projects, like to host your applications in a single data center between the different availability zones? Okay, some hands here and there. Great. And the third one, how many of you have an environment which is spread between several cloud vendors and act as a single solution? Okay, not so many, that was expected. For those of you with your hands down, you're on the right place, because after this session and during it, I'm going to share with you some real-world examples of how, what problems the multi-cloud can resolve for you. And for the rest with the hands up, I'm interested to speak with you after the session. But first, I would like to share with you who are we and what we are doing and why the availability topic is important for us. I'm part of the SAP Cloud Identity Services team, one of the most critical kernel services inside of the company. We are managing the authentication, authorization, and user provisioning for all the SAP customers and internal employees. Basically, when you need to access some of the SAP applications, when you buy one, we have to allow it. And as being in the center of the company, this means that when we go down, everything stops. From internal services to external customer business scenario. And I'll give you only one example, my favorite one, with a company called Shell. You should have heard of them. They have developed an application called Shell Skypad, which is basically running on a tablet, and they're using it to fuel the airplanes all over the world. And several years ago, during one of our outages, which are not so many, we managed to impact them. And this caused a massive traffic jam and delays on the airplanes all over the world. And this is only one of the examples for our customers. So this makes the availability topic important for us. And we consider a 3-minute outage critical. Thanks to the multi-cloud, we are able to increase our availability and to make our product flexible on infrastructure changes. And now let's address the elephant in the room. What does the real multi-cloud mean? Well, it means interconnected environments, making your application and product and platform cloud agnostic, meaning that it can be spread between several cloud vendors and act as a single environment of yours or a single region. The statistics shows that 89% of the enterprise companies have a multi-cloud strategy. But do you know what those companies understand of multi-cloud? They think that the multi-cloud is using different cloud products from different vendors together to build your software on. This is not what this session is about. We are going on the next level here. Because it's simple to take the database from Azure and the block storage from Amazon and build your product on top of them. And it's totally okay, by the way, because you're using best of both worlds. But you just made your product vendor locked, which is something we would like to avoid. There are many articles in the internet, IT podcasts, videos, stating that interconnecting your environments is something you should not do, because it adds too much complexity. It has many moving parts, and it needs more skilled people to operate. And this is true. Having a multi-cloud is increasing your complexity and raising your cost. And the question is, does it worth it? To answer this, you should first answer the how much question. How much will we have to spend in multi-cloud? How much efforts are needed? And if you take a closer look at those articles, you can see that they are dated several years old. Even the first one, multi-cloud is a trap, was dated 7 years ago. It was written there. So 7 years ago, we ran our production on virtual machines all over the place. And we all know what the virtual machine instrumentation, what skills are needed. They were different between the different cloud vendors. Nowadays, we have the technology which allows us to abstract those differences away, to interconnect our environments, and to achieve multi-cloud easier than before. Imagine that you could make your different environments talk to each other in a secure way over the internet. This is now possible thanks to the service mesh, mutual TLS, which is even more common these days. It allows you to bridge your environments together. What if I tell you that you could instrument your environments and applications the same way, independent on the cloud vendor they run on? This is now possible thanks to the Kubernetes, which gives you the common ground, which is the same everywhere. At this point, some of you might think, okay, multi-cloud is a bit more possible, a bit more achievable these days. But what is it for me? Why should I care about that? And I am going to give you four real examples of the things which I value about this solution and which we're using. First, it allows you to mitigate the vendor lock-in. Imagine that you receive a better price, better availability, or something better from a competitor. You can migrate without the fear of losing your service for a certain period of time, without the fear that you should invest and spend time in refactoring just to substitute one database with another. How to do this? Simple. Just run on Kubernetes. Put your database in. We're using that since many years, and it is successful. Second, you can not only move between the cloud vendors, but you can do it zero downtime without impacting your customers. We were in a situation where one of our cloud providers decided to sunset a data center we were running on. And thanks to the multi-cloud, we were able to spin up a new data center closer to the first one, bridge them together with a service mesh, interconnect the databases, sync the traffic, sync the database data, and then move our customer traffic to the second data center and stop the first one with zero downtime. No change management justifications. No customer impact, whenever we wanted to do. And this is something powerful. Third, multi-cloud helps also to fix latency and compliance issues. We are currently in a process of migrating to an external database. And because we have 18 production regions, for some of them, the database is far away from our servers. And for those, thanks to the multi-cloud, we are able to just do this zero downtime migration, move to a closer data center, and resolve our latency issues. Otherwise, we would impact our customers by having a longer response, which is not acceptable. It also helps you to fix compliance issues. For some customers, it's crucial their data to be located in a certain part of the world. And for them, you could choose either to run in a single data center, multi-zone, and accept the lower availability, or to combine several data centers in the same region, but from different cloud vendors, and raise their availability. It depends on the business critical case for your customer. So you have options. And the fourth one, multi-cloud, help you to avoid major cloud provider outages. And we all know that those things are not very common, but when they happen, the impact is usually massive, and it's not resolved within several minutes. And if I want to give you an analogy, I would compare the multi-cloud to the new car. See, they both are considered more expensive and more complex compared to the other options out there. But they both save time. The new car saves time from repairs. The multi-cloud saves time from downtimes and actually prolonged outages. And it is up to you to decide whether your time is worth the cost or not. As I've gotten older, I've come to value my time much more than before, because nowadays I simply cannot afford my family trip ruined because of a car breakdown, especially with a young child. The same principle is valid for the multi-cloud adoption. See, the largest enterprise companies simply cannot afford downtime and impact for their customers during prolonged outages. But is the multi-cloud always the right option? Definitely not. There are other two, which we're going to talk about, multi-zone and multi-data center. But first, to choose the right one for you, you should address the availability topic. It's crucial during the initial design. So from this table, I would like to emphasize that the more availability you aim, the less outages or the less downtime you would be able to afford, which at the end will bring your complexity up and also your cost. If we take the 3 nines availability, which is the most common availability used for most of the services, which are not considered business critical, this allows you to have more than 8.5 hours every year of outages. This means 43 minutes every month. This time is enough for you to wake up somebody and he or she to do some manual magic efforts to resolve your service, to revive it. It's enough time. And for this profile, you could go perfect with the multi-zone architecture. You can go with the multi-zone even with the 3.5 nines. Here, you can no longer tolerate outages more than 22 minutes per month. But if you invest some efforts in automatic tests and some other stuff to not bring down your system during an upgrade, you can survive with the multi-zone. If you need a bit higher availability, here the things are getting even more interesting. The multi-data center is perfect for this one, because here you cannot tolerate more than 4 minutes every month of outages. Here you should raise your complexity and invest in redundancy, self-recovery, and other mechanisms, which at the end will raise your cost. So what are the high availability options, which we mentioned already? Starting with the multi-zone, 3.5 nines. It's okay. Most of the cloud vendors are telling you that they will give you 4 nines if you host your service inside of their data centers and spread your applications between the different availability zones. So, but this is not feasible, because now, first, they won't achieve it every time, and second, you have zero window for maintenance breakdown, because those things happen. So the 3.5 nines is the availability which you should aim with the multi-zone, which, by the way, is the cheapest solution. Rising the availability, you should think outside of a single data center to the multi-DC. Multi-DC means same cloud provider, several data centers, which act as one environment for you. The private network is the same. And if you need to go even higher with the availability, then you should choose the multi-cloud, because multi-cloud can help you to survive in global outages. In our team, we're using all 3 architectures, depending on the customer case. So let's talk about our architecture. We rely on the same thing deployed everywhere, meaning that one of our regions, independent QA, production, staging, whatever, is the same. 3 landscapes below. You can think of a landscape as a set of servers enough for you to operate your product on, but we have 3, because the database is inside of our Kubernetes, and because we need connectivity, and because we need to survive with 1 landscape down during an outage. The rest 2 will continue to serve the customer traffic, and it will give us enough time to resolve the problem with the first landscape without impacting our customers. Moreover, we have invested in DNS failover mechanism. Basically, each of our regions have an URL, and the IP below is under our control. Whether the first landscape will receive the traffic or the second one, those actions are automatically synchronized and done from this system, which is external. We are using Akamai Global Traffic Manager, but there are others. Many of them are offering the same principle. We also have added Kubernetes everywhere. And not only that, but we are using it as a service provided by SAP team called Gardener. Maybe some of you have heard of them. So this allowed us to now move away from the OS patching and OS maintenance anymore and focus more on other DevOps stuff. We also introduced the service mesh everywhere to all of our environments because we wanted the freedom to choose what to do with them, how to migrate them without the impact. And by adding more things on the table, we have to address the design, and it should be common. To reduce the complexity, we needed interchangeable components and centralization on more places. So now let's talk about how those components allow us to achieve our availability goal. Starting on our regional concept, this is an example of a multi-zone. And here we have a single data center, and our landscapes are spread between the different availability zones. The private network is the same, provided by the cloud vendor, and the availability was 3.5 nines. Now, here, this is a multi-DC. Basically, it's the same picture, but now instead of different zones, we have different data centers provided by the same vendor. The communication can be private, if you wish. By having the automated DNS failover mechanism on top, we are serving the traffic with this landscape, and in case of failure, the traffic is forwarded automatically to the second data center between 1 and 3 minutes worldwide, which is powerful. So we also, since we added Kubernetes to the picture, now our landscapes, each of them is a different Kubernetes cluster, which allow us to survive with a Gardener cluster downtime, a Kubernetes cluster downtime, which also give us some more higher availability. And by adding the service mesh into the table, now we can run our different landscapes in different cloud vendors and make them talk over the internet using mutual TLS. By having that, we're able to achieve even more than the 4 nines availability. So by adding more components to the table, as I mentioned already, we have increased the complexity for our service. And for that, we needed a common design, interchangeable components, the same set of software deployed to all environments, minimum differences, centralized solutions for management, which at the end limited the complexity. As I mentioned, one word, centralization. We rely on the central Git repository, which is hosting the code for the deployment of all of our environments. One repository. Before we had 4. Also, all of our Docker images are infrastructure agnostic. The same image deployed everywhere. The changes needed for the environment to function are deployed with Kubernetes config maps and secrets. Those are different from the image. And the image is then signed, packaged, and uploaded to a central Artifactory storage available to be consumed for all of our environments. We are using Kustomize to structure our Git repository to be able to achieve 95% of our code to be the same, basically. And the rest 5% is Delta, and it's added on top of the manifests thanks to the Kustomize overlays, which we are using. We are also invested in central secret storage, and for that, we are using HashiCorp Vault. As a continuous integration system, we decided to go with the Jenkins because we were having a long history with it, and it's the one responsible for our code build, image signing, automated tests, and even it instruments our continuous delivery process. And for that, we go with the ArgoCD. Why? Because we wanted to have a central place for Kubernetes orchestration. The changes have to be visible for us, whether the change hit our system and it was successful or not. So we also wanted to be in control of what is delivered to which systems and when. So for our most business critical scenarios, we are able to deploy the changes on demand and also automatic if you want. And I would like to finish with a strong sentence. Multi-cloud is not a trap, but is a way forward. And I would like you all to think for your customer scenarios and for your product needs. And after this session, answer the following question. Can you benefit from multi-cloud or not? Thank you.
Okay, so we have 5 minutes for Q&A. Someone?
The gentleman over there.
Yeah, we have.
Hello. So my question is, you said that you have, for example, a database which is hosted on Kubernetes directly, right? So how are you balancing? It seems to me like a trade-off. If it is not, correct me. If it is, how do you balance the trade-off between having to manage this database and any other infrastructure yourself versus outsourcing it to the cloud providers managed, say, database, publish, subscribe, whatever?
Well, if we move our database to, for example, an Amazon database, it will be located at some part of the world. And if you want to move our region to another one, we should sync to the same cloud vendor database, right? If we want to switch to the cloud vendors, we are not able. So we are vendor locking our database to a certain cloud vendor. I mentioned that we are now in a process of migrating towards an external database, and it is SAP HANA. So SAP HANA, some of you might know it, but it's basically the same thing. Why we choose SAP HANA? Because we have to choose SAP HANA, because we are SAP. So that's the reason. For me, there is no trade-off. If the database is inside your Kubernetes, there is no problem. We were running in MongoDB since many years without any problems. Yeah. Yeah. The trade-off is that we are a bit more database administrators at some point, but it's still manageable for us.
Yeah.
I have a question on the slide with the infrastructure providers. There was Azure, AWS, and another one, CC3. What is this one?
CC3 is an internal, it's Converge Cloud. It's internal SAP Cloud provider, which we are using for maybe half of our production environments, and the rest are spread between Azure, AWS, and GCP at this point. So we are running in 4 cloud providers at this point.
Thanks.
There is a question from the hand.
Thank you. If you can show again the slide with the percentages of the availabilities. You mentioned that the multi-cloud is for going from 3 nines and a half to 4 nines or up.
No, multi-data center is to go to the 4 nines. So multi-zone was the first one. It was able to, by using it, you are able to achieve.
The table with the availability percentages.
Oh, okay. Just a second.
It was one of
you
the
mean
first
this one?
Exactly.
Okay.
So multi-cloud is somewhere below the 4 nines.
Yeah, it's below 4 nines.
Yeah. My question is, by what margin does the cost increase for going in that step compared to the previous step?
Well, the exact margin, I have not done the calculations, but with the multi-data center, you're basically using the same thing. You are combining several data centers to speak together. By going to multi-cloud, you need to invest in also service mesh, which increases some of your resources and resource consumption of your clusters. But it's something like 5% or something like this.
So
it's
basically
not too
the big
high.
jump is from
It's from multi-zone to multi-DC, yeah.
Okay.
Because here you're running in a single data center, and here you should have 3.
Which basically triples the cost.
Yeah.
Okay, thanks.
But from those 3, 2 of them may serve your customer traffic 50-50. And the third one is for the database clustering, so it's with less resources. So if you have to think of the resources, because in SAP we are thinking more over the availability topic. But still, you can lower the resources on those landscapes and at the end get some benefits about the availability as well. Okay. So thank you all.